discuss some factoring methods. Just really, it's kind of the same method. It's just different methods for organizing your work. I am just focused on the factoring part of this right this second, not the equal 0 part or finding the x value. This is literally just the let's get it factored. So, all of these methods start off the same way. And that is, we take our A, which in this case equals 2, and our C, which in this case equals 10, and we multiply them together. So our AC is 20. We then have our B value, which in this case is negative 9. And we need two numbers that add to give us 20. So m plus n must, add to give us negative 9. M plus n must add to give us negative 9. They must multiply to give us 20. And what we have here, 5 and 4 do add to give me 9. If they're both negative, they add to give me negative 9. And they do multiply to give me positive 20. So these are the two numbers that we are working with here. Now, the first method that I'm going to show you is the method that I tend to use when I'm working these out personally, and that is the greatest common factor. Okay, so 2x squared minus 5x minus 4x and plus 10. So in my grouping, I look at those first two. I find that the greatest common factor is just x. And if I factor out an x, that leaves me with 2x minus 5. Now with these two, I look at these and I see the greatest common factor is a 2, which will give me a 2x and a 5. Now, this sign is positive, whereas this sign is negative. So to make those the same, I need to pull out a negative 2, so that I have negative 5. So now I have two factors that are in both of my terms. So I can factor the greatest common factor, which is this 2x minus 5, out, which leaves me with x minus 2, and then both of these get factored out to give me my 2x minus 5. And this is the factored form of my original equation. One last method, and this one we've looked at in class. But again, like all of our methods of organization, they start off the same. We need to figure out what our A is. Our A in this case is 9. We need to know what our B is. Our B in this case is 20. And we need to know, okay, I'm going to be editing here as well. Let me go back to the top. Okay, the third method that we're going to discuss, we have discussed in class. And it starts off the exact same way as every other one. We need to know what our A is, in this case it's 9, and we need to know what our C is, in this case it's 20. We also need our B, which is 31. Now we multiply A and C together to get, in this case, 180. So we are looking for two numbers that add to get me 31, but multiply to give me 180. So add to give me 31, multiply to give me 180. If you don't ever know these off the top of your head, that isn't a problem. Sometimes it's just a case of having to do a little bit of extra setup just to make sure that we can get everything right. So we can always kind of factor this out. This will give me, I know, 18 and 10. Now 18 I know is 9 and 2, 10 I know is 5 and 2. And actually, once I get here, I have jogged my brain, because I know that 9 and 5 is 45, and 2 and 2 is 4. And then if I do 45 times 4, I get 180. Okay, so I now have those two numbers. You might have come by them more quickly than I did, but I have them. Now, why is that useful? Well, what we're going to be doing is we're going to change this, and we are going to make this into x squared plus 31x plus 180. And the reason we do this is because we know exactly how it looks as a factored product. It's, in this case, x plus something times x plus something. And the two somethings that we have are right over here. So we have x plus 45 and x plus 4. These are our intermediary steps. These are the basis of what we're going to be doing now. So we have x plus 45, and we're going to divide that 45 by 9. And that is, of course, going to give us x plus 5. So this is one of my two factors. The other factor, x plus 4 divided by 9, well, those don't go into each other. But I can rewrite it as 9x plus 4. So what we have as our final factored product, the final answer, is x plus 5, 9x plus